Have you ever wondered how a giant cargo ship weighing hundreds of thousands of tons can stay almost perfectly still in the middle of the sea? The answer lies beneath the water, in its massive anchor. But here's something surprising. It's not just the anchor's weight that keeps the ship in place. When a ship reaches its destination or needs to stop offshore, the crew slowly lowers the anchor using a powerful hydraulic machine. The anchor sinks to the seabed while a long, heavy steel chain continues to unroll. Instead of hanging straight down, the chain stretches across the ocean floor. This small detail makes a huge difference. As wind, waves, and ocean currents push the ship, the anchor is pulled horizontally. Its specially designed flukes dig deeper into the sand or mud, creating an incredibly strong grip. The more the ship pulls within safe limits, the deeper the anchor buries itself, increasing its holding power. The anchor chain is just as important as the anchor itself. Because the chain is extremely heavy, it keeps the pulling force low and almost parallel to the seabed. This prevents the anchor from being lifted out of the ground. The chain also absorbs the constant motion caused by waves, reducing sudden shocks that could loosen the anchor. During rough weather, a properly set anchor can safely hold an enormous ship. In stronger storms, captains may deploy two anchors to improve stability. However, if a hurricane or extreme weather approaches, ships often leave the anchorage and head into open water, where they can safely maneuver instead of remaining fixed. Many people believe an anchor can instantly stop a moving ship, but that's actually a myth. A fully loaded cargo ship has enormous momentum. Dropping the anchor while the ship is traveling at high speed could damage the anchor, snap the chain, or even harm the ship itself. That's why captains always slow the vessel using its engines before lowering the anchor. The anchor is designed to hold a stationary ship, not to act as an emergency brake. When it's time to leave, the crew uses a powerful windlass to pull the chain back on board. As the tension increases, the anchor breaks free from the seabed. Any mud or sand is washed away, and the anchor is secured back into its housing before the ship continues its voyage. Modern ship anchors are engineering masterpieces. Some weigh more than 30 tons, while their chains can weigh hundreds of tons. Together, they create one of the most reliable systems ever designed, allowing some of the world's largest vessels to remain safely in place despite wind, waves, and powerful ocean currents. So the next time you see a giant ship standing still in the middle of the sea, remember, it's not simply being held by a heavy piece of steel. It's the perfect combination of engineering, physics, and an intelligently designed anchor system working silently beneath the waves. One question still remains. What happens if the anchor loses its grip? This can happen if the seabed is made of loose rock, thick seaweed, or hard coral, where the anchor cannot dig in properly. In that situation, the anchor may begin to drag across the ocean floor instead of holding the ship in place. Modern ships are equipped with advanced GPS systems and electronic navigation equipment that constantly monitor the vessel's position. If the ship starts drifting even a short distance, the bridge immediately receives an alert, allowing the crew to react before the situation becomes dangerous. Another fascinating fact is that sailors don't simply drop the anchor and hope for the best. Before anchoring, they carefully study the depth of the water, the type of seabed, wind direction, tidal changes, and ocean currents. Based on these conditions, the captain decides exactly how much anchor chain should be released. In calm weather, less chain may be enough, while rough conditions require much more chain to create maximum holding power. Even with today's advanced technology, the basic principle of anchoring has remained almost unchanged for centuries. Engineers have improved the materials, strengthened the chains, and designed more efficient anchors, but the science behind the system is still the same, allowing the anchor to dig deep into the seabed while the heavy chain keeps the pulling force low and stable. It's remarkable to think that one carefully engineered system hidden beneath the surface can control a vessel larger than many skyscrapers are tall. Every time a giant cargo ship, oil tanker, or cruise ship remains safely in one position, it's a perfect demonstration of how physics, engineering, and human innovation work together. What looks simple from above the water is actually one of the most reliable and impressive technologies ever developed for life at sea.